Coding, the mysterious force that drives computers. But is it really that mysterious? Hello, I am Aiden, an 8th grade student in Western Academy of Beijing that enjoys coding. I'm here today to bring you a presentation regarding what coding is, why you should code, and how to learn to code. So, regarding this, let me just first tell you a story. So in January this year, I was doing some coding questions during transition time. A student comes up to me and asks this question. Oh, so you're doing real coding? Of course, I reply yes. He then says that it is cool before walking off to class. I also walk off to class a few minutes later, still confused as to why he had to ask this question in the first place. And after a bit of thought, I decided to make this TED Talk about this. From this, it's quite obvious that many students are not exactly very clear about what coding is. They have a variety of beliefs about it, ranging from the purely anecdotal, such as how it's cool, to the blatantly wrong, such as how coding is only used for hacking. Modern media only further reinforces this fact. For example, in The Matrix Resurrections, the hacker, Sequoia, literally just looks at some green text, presses a few buttons, and then miraculously understands what's going on. In reality, of course, it's different. Coding may be perceived as cool by many people, me included, but it's often quite boring. Coding isn't only used for hacking. As previously mentioned, it's used everywhere in computers. So, now with that misconception out of the way, what exactly is coding? Well, coding is essentially telling the computer what to do using a series of ironclad rules. For example, you can't just tell the computer, oh, tell me the total of these two numbers I give you. You have to tell it, input these two numbers, add them together, and then output the results. For example, in this program, although it may look scary, it essentially just includes some functions or words for the computer that it needs, inputs two variables, and then outputs their total. Of course, not everything is perfect. Often, after you finish writing your program, and you then run it, and then the system starts breaking down again. It starts yelling at you about things like, oh, syntax error, something is not a legitimate function, etc., etc., etc. Needless to say, try to make sure that you're writing the proper programs, and try not to do that. So, why should you code? Well, I think we should split this mainly into two parts: competitive programming and applicative programming. Competitive programming is where you write short programs using a bunch of specialized algorithms, or essentially programs, to solve certain questions in competitions. Then you have applicative programming, which is essentially creating games, creating apps, creating functions. For competitive programming, you can learn problem-solving skills, and you can also learn some actually quite useful algorithms. For example, you can learn how to find a path throughout a 2D map. In comparison, for applicative programming, you learn perseverance, as making games and applications often takes weeks. And you can also share them with your friends. Great fun. So enough of the boring stuff. Let's explain a game I made. So this was a game I made in 2021. Hold it. Can somebody play the video? Hello? So this was a game I made in early 2021 with around 1 or 2 months of work. I used a coding language, essentially a computer-readable program called C++, with an extra library or a set of words for the computer called SFML. Essentially, this allows you to create these things called sprites. They're objects that you can move around, stick an image on, and rotate. So Everything that you can see on screen that moves is a sprite. The triangles are sprites which have a red triangle image stuck onto them. The blue square, similar. But all of them are moved every 60th of a second, in order, and this allows them to look like they are moving in fluidly, though of course it's only an illusion. And the red triangle follow a predetermined path. The blue square is controlled by the player. I maybe tried a bit too hard while doing this. Yeah, great fun, as I just said. So, how do you learn competitive programming? It's pretty simple, as once again you're preparing for competitions. There's not much extra stuff you can do. You learn a program. In this case, I'm using C++ as an example because I learned it. You set up a programming system. I recommend using tutorials online for this. You enroll in some form of course, and you enter competitions. There are some links that might be a bit unclear. But essentially, there are three main competitions: the CSP, USACO, and ACSL. The CSP is a Chinese competition. The USACO and ACSL are English competitions. Essentially, all of them are relatively similar, though the problems they give you, just like the problems in various different math competitions, may be slightly different. For applicative programming, everything is a lot freer, because once again, you're making your own games and applications, not like following some highly structured competition. The two examples I'm using here are JavaScript and C++. I've learned both of these programming languages. For JavaScript, Khan Academy actually has a system that runs it. So essentially, all you need to do is go to Khan Academy, create an account if you haven't already. I'm assuming most of you have, though. And then they have some pretty in-detail courses for how to do JavaScript. After that, all you need to do is create a new program and start programming. For C++, you can use the previously mentioned SFML. Essentially, you download the extra library on their website, and you start programming. Though this may be harder because their tutorials aren't that detailed. All right. Anyways, if you have spare time, maybe try learning coding, and thank you for listening.